Today we're going to run through Lesson 7, Passive Buzzer. For this lesson we'll be needing the Mega 2560, a passive buzzer, and 2 F to M wires. Let's check out the lesson plan. Alright, the lesson plan objective is to learn how to use the passive buzzer. The purpose of the experiment is to generate 8 different sounds, each sound lasting half a second. The 8 sounds each operate at a different frequency. In this case, the ranges are low to high. The order is Do, Re, Mi, Fa, Sol, La, Si, Do. The passive buzzer is a new component that the lesson plan introduces. The working principle of the buzzer is to use PWM, or pulse width modulation, to generate audio by making the air vibrate. For example, sending a pulse of 523 Hz will generate the alto do sound. Let's move to the wiring diagram. It looks like we'll be using the D8 PWM and ground pin connectors. The wires will then connect to the positive and negative terminals on the passive buzzer. Now, the code is surprisingly not spoken about in much detail for this lesson, so I took the liberty of doing some research to try and understand it. I'm going to try to explain it to the best of my ability to you. First off, the include pitches.h line of code requires us to have the pitches library installed. So that's the first thing that we want to do. So we're going to click sketch, include library, add .zip library. We're going to look for the Eligo master folder. In this case, it's in my on my desktop. So English, libraries, and we're going to click pitches and open that and unzip it. I've already done it so. The code specifies melody as all of these musical notes, which I'm guessing was pulled from the pitches library that we installed earlier. It then specifies a duration for each melody, which is 500 milliseconds, or in this case, you could also say half a second. Void loop is a little trickier. The first line of code sets a range from 0 to 8, and that range is specified by this note. This note is just a generalization for the 8 different tones that are played. Those tones are played in order, and that order and duration is specified by the next set of code. That next set of code is right here. This specifies the output pin as 8, the melody and its order as this note, and the duration which was specified as half a second. The next line of code sets a 1-second delay before starting the output, and the last line of code sets a 2-second delay before looping the output again. Okay, with all of that out of the way, let's build it.